Okay, gas stoichiometry. Again, there are two different types of problems that you can kind of get with this. I like to kind of focus my students on looking at liters. If you're given liters, you're going to start with the ideal gas law and then use stoichiometry to get to your final answer. Or you could be looking for liters, in which case you would kind of do the opposite. You would start with stoichiometry and then use the ideal gas law. When I read this problem, I clearly see a value for liters here. I am given liters. The value is right there. So this type of problem, I'm going to start by using the ideal gas law and then plug in my answer, use a little bit of stoichiometry to get my final answer here. So first thing I'm going to do is write out the ideal gas law. PV equals nRT. There it is. And right from the problem, I can plug in quite a bit of information, except for moles. There's no moles given. I have liters here, and then this STP, even though it doesn't say it, I know immediately a value for temperature and a value for pressure. So I'm going to go ahead and plug those things in. My standard pressure, which you should know, is 1 atmosphere. The volume given in the problem is 25 liters. I'm looking for moles, so N is going to be my unknown here. The gas law constant is always the same number, 0.0821. Has kind of scary units. That's okay. You can do it. Liters times atmosphere divided by mole times Kelvin. And then my standard temperature should be 273 Kelvin. Wonderful. How do I isolate this for N? How do I isolate my unknown variable here? Well, here's my unknown. If I want to get N on one side of the equation all by itself, what makes sense to me is I will have to divide both sides by 0.0821 times 273. And I'm getting lazy there, not writing my units. It's going to cancel out on this side, and you'll be left with nothing but N on the right side. And remember, whatever you do to one side of the equation, you have to do to the other. And I'm going to write this actually a little bit different on this side, 0.0821 times 273, and I'm doing that for a reason. When you punch this into your calculator, you have to remember to use parentheses in your denominator. Otherwise, your calculator wants to, divide first? Yeah, it wants to divide first rather than multiply first. So when you punch this into your calculator, you punch in 1 times 25 divided by, open parentheses, 0.0821 times 273, close parentheses, and that should get you a final answer. Let me clear this all out so I don't run out of space here. That's how I solved this equation for N. Once you solve it, your number of moles should be about 1.1 moles, and that's of hydrogen gas. A lot of students ask me, how did you know your unit was hydrogen gas here? Well, I got it from the problem. I started with 25 liters of hydrogen gas. So if I plug that into the ideal gas law to solve for moles, I'm going to end up with moles of hydrogen gas. That's where that unit came from. Now I can dive into a little bit of stoichiometry here. The problem has asked me to find grams of sodium. So let me underline that. It says mass of sodium here. And I've got moles of hydrogen gas right now, which is useful to me. I can use it by using my mole ratios. So before I do any stoichiometry, I'm going to double check and make sure I have a balanced chemical equation. Sometimes you have one that's balanced, sometimes you don't. In this case, it has already been balanced for you, so my mole ratios should be correct. If I follow my units, if I have moles of hydrogen gas up top, that means I have to have moles of hydrogen gas down below. And I want to look at my mole ratios. I can't get to grams of sodium, which is what the problem wants me to find, but right now I certainly can look at moles of sodium, right? That's easy enough to find. Where do I find these mole ratios? Well, all you have to do is look at your balanced chemical equation. In this case, I see a 2-to-1 ratio. It's just your coefficients. That's all you have to plug in. So I'm going to put 2 moles of sodium up top and 1 mole of hydrogen gas down below. If I were to stop here and solve my equation, I would end up with moles of sodium. Is that what the problem asked me to find? Well, no. It wants the mass of sodium. So I'm going to actually tack on one more conversion here and simply convert from moles to grams. So 1 mole of sodium has how many grams? Well, I have to check my periodic table it should be 23 grams of sodium. Now I should be ready to solve. How do I solve this equation? You multiply everything that's up top. Multiply 1.1 times 2 times 23. Then you'll divide by everything in the denominator. So divide by 1, divide by 1. Obviously, in this case, dividing by 1 really isn't going to change your answer, but it's still good to get in the habit of dividing by everything in the denominator. Once you punch that in your calculator, you should end up with something like 50.6 grams of sodium. There, now we can go back and double check. Did I answer the question? Is my final answer in grams of sodium like they asked? Yes, I got the final answer in grams of sodium. The key here is this bridge step. You're connecting from moles of hydrogen gas to moles of sodium. You can connect using those mole ratios and then just convert back to grams. Best way to study these is to just practice. You know, go online, go on Google, search for more practice problems, even open up a textbook. Yes, I know, dare I say those words, and just solve more of these problems. See if you can get them right. Hope this video helped. Good luck.